meeting is being recorded.
Okay, we're going to take a look at the midterm review, version A. This video is for the first half of the review. Okay, starting with number 1 here. This isn't the only way to do this problem, but in my opinion, it's the most efficient way to do it. So I noticed this 12xy to the 5th is raised to the negative 4th power. I'm going to go ahead and move that down to the denominator as a group. And if I move it down there, then that exponent that is a negative 4 becomes then a positive 4. The other thing I'm going to do so that I don't have to figure out what 12 to the 4th power is, that's kind of a big number. Since both of these are to the 4th power, I'm going to go ahead and make it into just, a quotient here, raised all to the 4th power. So I'm going to choose to reduce first before raising everything to the 4th power. But again, this isn't the only way. This is just, in my opinion, the most efficient way to do this problem. So I can reduce here, let me get a different color. 3 and 12, they share a common factor of 3. So I'm going to divide both of these by 3. Let's see, something's blinking down here. What is this telling me? Meeting controls, I don't know. Sorry about that. I just saw something blinking down there. I want to make sure I was still recording. Then with the exponents, we subtract them. So the top, we have an x to the 4th. Bottom, we have an x to the 1st. 4 minus 1 is 3. So that would mean an x to the 3rd. I do put my answer back where the big one started. With the y's, and let me go ahead and put my 4 down here because I reduced 3 over 12. With the y's, 5 minus 3 is 2. So I'm going to have a y squared. And I'm going to put it in the denominator. This is because y to the 5th means I have 5 y's in the bottom, only 3 y's on top. The 3 y's in the top would cancel with 3 of the 5 y's in the bottom. I would have 2 left. And then finally, I'm going to raise everything to the 4th power. So the x to the 3rd is going to get raised to the 4th, as well as the 4y squared. When I raise a power to a power, I do multiply my exponent. So the numerator becomes x to the 12th. In the bottom, 4 to the 4th is 256. Remember, that's 4 times 4 times 4 times 4. So 256 would be that. And then it would be y to the 8th, because once again, I have a power to a power, so I'm going to multiply those exponents. All right, number 2. We want to simplify this square root. I like to do a factor tree with the numbers. Okay, again, not the only way to do something like this. 72 is 8 times 9. 8 is 4 times 2. 4 is 2 times 2. I'm trying to get down to all prime numbers. So now I've got a bunch of primes. And if you have 2 of a kind, because we have a square root, 2 of a kind, we can bring a number in front. So let me just start with, I'm not going to not worry about the variables just yet. So with the square root of 72, this is 2 times 2 times 2 times 3 times 3. If you have 2 of a kind, you can bring that up front. So I have 2 2's, means I can bring a 2 in front. I do just bring 1 2, not both of them, because it's the square root of 2 times 2. I also have 2 of a kind here, and so I'm going to bring a 3 in front. We do multiply those numbers that are brought in front. So the square root of 72 is 6 square root 2. Now, I also have to simplify the variables. With the variables, what I like to do is take the exponent and divide by the index, which in this case is a 2. 11 goes into, I'm sorry, 2 goes into 11 5 times, which is 10, and the remainder is 1. The 5 becomes your exponent on the outside, so we're going to have an m to the 5th on the outside, and the remainder is your exponent under the square root. So we're going to have an m to the 1st underneath. This is because we're going to have 5 groups of 2 m's, and then there'd be a single m left over. So that's why that works that way. With the 24, 24 divided by 2, 2 goes in 12 times, which is 24, and the remainder is 0. So this means I'm going to have an n to the 12th in front, no n underneath the square root. So final answer, putting it all together, we have a 6 in front, that comes from there, an m to the 5th, that comes from there, an n to the 12th, because of that. Underneath the square root, I have a 2, and an m to the 1st. Since the remainder was 0 over here, I do not have any n's left underneath the square root. All right, number 3. With number 3, I want to factor. I've got some trinomials here that have a GCF. So we're going to want to get that GCF out first. So I notice that the first trinomial, I have a GCF of 2. So let me go ahead and factor that out first. I'm going to go ahead and just rewrite this trinomial in the first denominator does not have a GCF. So let me just go ahead and rewrite that. Speaking of GCFs here, I could take out a 5. Go ahead and get all my GCFs out first. And then in the denominator, I have a GCF of 4. So let me take that out. Okay. So in this first step here, I just factored out a GCF from all of the polynomials. Okay, now I'm going to go a little bit further. With my trinomials, they factor as long as I can find 2 numbers that add to -4 and multiply to 3, add to +1, I want them to add to 1, multiply to -12, and add to 6, and multiply to -7. So I am going to be able to factor all of those trinomials. That's just kind of the quick trick when the leading coefficient is a 1. Okay, so don't lose your GCF, it stays there. 2 numbers that add to -4 and multiply to 3 are -1 and -3. In the denominator, add to 1, multiply to 12 would be +4, -3. Okay, second numerator, I can't do anything with that. I'm just going to copy it down. And the denominator, add to 6, multiply to -7. So how about +7, -1? Now what we do is we cross cancel if possible. We could also cancel up and down, meaning that I can cancel this common factor of x minus 3. As long as one of the factors is in the numerator and the other is in the denominator, we can cancel. I can also cross cancel here. I can also cross cancel here. So we got rid of all the binomials. With the numbers, we're also able to reduce those. The 2 and the 4, I can cross cancel. So we have a common factor of 2. So I'm going to divide 2 by 2 to get 1 and divide 4 by 2 to get 2. So also look to reduce those numbers. So it looks like the only thing I have left in the numerators is the number 5. In the denominator, I have a factor of 2 and a factor of x plus 7. So we were able to get rid of a lot of common factors. Number 4, to add these, we do need a common denominator. So I'm going to start with the numbers. The first denominator has a factor of 2, and the second has a factor of 5. The least common denominator, or the least common multiple of 2 and 5, would be 10. So I need to multiply this one by a 5. Whatever I do to the bottom, I've got to do to the top. And this one times 2, top and bottom. So I'm not quite there yet, but let me go ahead and write this down. So I've got 25 over 10 a b to the 14th plus 18 over 10 a cubed b to the 13th.
This meeting is being recorded.
So both denominators, they both have a 10, but we also need their variables to match. So the first denominator only has 1a, the second one has 3. So I'm going to multiply by a squared, top and bottom, so that both denominators would then be a cubed. With the b's, the first denominator has 14, second only has 13. So we need another b over here. Now we should have a common denominator. So let's check it out. So let's see, the first fraction, or the first rational expression, becomes 25a squared over 10a cubed b to the 14th plus, then we have an 18b over 10a cubed b to the 14th. So now that we have a common denominator, we can add numerators and retain that common denominator. When we add the numerators, they are not like terms, so I can't do much better than that. And I also cannot reduce this at all. Remember, to be able to reduce, you've got to have a common factor from all 3 of the terms. And although this first term has an a squared and the denominator has an a cubed, the second term of the numerator does not have an a, so there's not a common factor from all 3 of the terms. Okay, number 5. For this one, to solve for b, we are going to want to first clear fractions. And by the way, you can't just say, okay, every numerator is 1, so I'll just get rid of those. That doesn't work. It would work if all denominators were the same, but not all numerators. So I'm going to multiply both sides of this equation by the least common denominator, which would just be ABC. All denominators are different. So least common denominator would be ABC. On the left-hand side here, don't forget to distribute. So I'm going to multiply. So let me show my work here. So if I take ABC, and I could put it over 1 if I want, and I multiply times 1 over A, the A's would cancel, and I would just be left with BC. So when we take ABC times 1 over A, we get BC. If I take ABC, again, I can put it over 1 if I want. If I multiply times 1 over B, the B's would cancel, and I would have AC. On the right, I'm going to have AB. Same thing, the C would cancel with the C, just be left with AB. Now if I want to solve for B, I need to isolate the terms that contain a B. So this AB here, I'm going to subtract it over, so minus AB, That way the 2 terms that contain a B are together. I'm also going to move this AC over to the right. To move it over, I will have to subtract it. So subtract it from both sides. So this will be gone and that'll be gone. So on the left, I'm going to have BC minus AB. Again, they're not like terms, so I can't actually do anything better than that. And then this is going to equal negative AC, because I did subtract that AC from both sides. Trying to isolate B, I can factor it out. So it's a GCF on the left. And then the last thing I want to do is divide both sides by C minus A. So that's going to get me the B all by itself. So final answer, B equals negative AC over C minus A. Number 6, we have a word problem here. It says Matt scored 91 and 86 on his first 2 tests. What score does he need on his third test to have an average of 90? So to find an average, we take all the observations, which we don't know the third, so I'm going to call it X. We divide by how many observations there are. There will be 3. He's going to take 3 tests. And this is equal to the average. So we're missing, the third test score. So that's why I used a variable there. So adding the 3 test scores and dividing by 3, we want that average to be 90. 91 plus 86. So let's see, that would be, 177. So I just went ahead and combined like terms in the numerator. I can clear my fraction by multiplying both sides of the equation by 3. So that would get rid of that. So we now have 177 plus X equals 270. And then if I subtract 177 from both sides, then I have that X equals 93. So he would need a 93 on test 3 in order to have an average of 90 in the class. Number 7, we want to solve by completing the square. For this one, since it specifically tells us to complete the square, it is a quadratic equation, but on the exam, it does specifically say that if you use a different method, you would only receive 1 point for a correct answer. So make sure you know how to complete the square. To complete the square, the first thing we need to do is divide by the leading coefficient. If it is not 1, we cannot complete the square unless our A, that leading coefficient, is a 1. So I'm going to divide both sides of the equation by 3 to get x squared minus 8x minus 11 equals 0. The next thing we do is we do move the constant over to the right-hand side. So I now have x squared minus 8x equals 11. Now we're ready to complete the square. Completing the square is going to create a perfect square trinomial on the left-hand side. To complete the square, we take I guess I'll write it down here. We take the coefficient of x, so coefficient of x, we divide it by 2 and square the result. So in this problem, the coefficient of x is negative 8. We're going to divide it by 2, square the result. Negative 4 squared is 16. So I'm going to add 16 to both sides. So I'm moving up here now. So we have x squared minus 8x. I'm going to add 16, and I'm just going to do it in a different color so it kind of sticks out. So that result I got, 16, and I do need to add it to both sides of the equation. Whatever you do to one side, you have to do to the other side. We have now created a perfect square trinomial on the left-hand side. It will factor as x minus 4 quantity squared. If you correctly complete the square, you will have a perfect square trinomial on the left-hand side every time. On the right, 11 plus 16 is 27. Hey, to finish, I'm going to use the square root property. Basically, it says I can take the square root of both sides of an equation. Don't forget the plus or minus, though. It's part of the square root property, so it is plus or minus. So we get, so the square root of x minus 4 quantity squared would just be x minus 4. Plus or minus 3 square root 3. To simplify the square root of 27, I'll show it up here. If you find its prime factorization, it would just be 3 times 3 times 3. And as we saw earlier in the video, anytime you have two of a kind, you can bring that number in front. So that 3 would go in front there. So 3 square root 3. And then the last thing I'm going to do is isolate the x by adding 4 to both sides. And then now I've successfully solved that quadratic equation. So x equals this plus 4. Typically, you're going to see it in front of the plus or minus so that there's no confusion about whether it goes under the square root or not. But technically, it is not incorrect if you want to put the plus 4 in the back, but you're going to typically see it in front of the plus or minus. The next one does say solve by any method, so you have your choice. First thing I'm going to do is I am going to distribute the z. The left side is factored, but I don't have a 0. So it's not helpful to have one side factored if you don't have a 0 on the other side. So distributing, I'm going to get 12z squared minus 7z. This is equal to 10. I'm going to go ahead and subtract over that 10. So I do have a 0 on one side of the equation. Now it does say solve by any method. I definitely wouldn't complete the square. We just did that, and you'd have to divide through by 12, and none of the terms are divisible by 12, except for the first one. So that would be really tough to complete the square. So I would either factor or use the quadratic formula. This one does factor. I know that because I wrote this question, so it does factor. But I think I'm going to use the quadratic formula. I just feel like there's a lot more flexibility with it. So let's look at the quadratic formula. So the quadratic formula says that z would be negative b plus or minus the square root of b squared minus 4ac all over 2a. Our a is the coefficient of z squared, which is 12. Our b is the coefficient of z, which is negative 7. And our c is the constant, negative 10. So we just plug and chug into this formula. So negative b would be positive 7. When you square b, b is negative 7, you get 49. B squared is always going to be positive because you're squaring that. Minus 4 times a, which is 12, times c, which is negative 10, all over 2 times a. Now, underneath the square root, kind of looks like we're going to get a negative number, but we're not. Sorry, my 4 looks kind of funny. Let me see if I can get rid of that, make it look better. We're not going to be, because although we are subtracting, what follows the subtraction symbol is a negative number. So it's going to be minus a negative, which is going to end up being plus plus. So let's see, if I take, I'm just going to do this second part here. So if I take 4 times 12 times negative 10, I get a negative 480. So we've got 7 plus or minus 49 minus negative 480. So this is what I was talking about, where we're going to end up doing plus plus there. And then all over 24. So let's see here. 7 plus or minus the square root. So if I add 49 to that, that would be 529 underneath the square root. Now, 529 is kind of a big number, but it actually is a perfect square. So let's see, if I take the square root of 529, I get 23. So we have 7 plus or minus 23 over 24. So I completely got rid of the square root because I had a perfect square underneath. I can't reduce this at all. 7, 23, and 24, they don't have a common factor other than 1. But I can do better than this. I can simplify. So one of my answers would be 7 minus 23 all over 24. And the other answer would be 7 plus 23 all over 24. So one of my answers would be negative 16 over 24, because that's what 7 minus 23 is. And the other would be 30 over 24. And then I could reduce those to get my final answer. So negative 16 over 24 reduces to negative 2/3, because 8 would be the greatest common factor. 30 over 24 would reduce to, let's see, how about 5/4? Because 6 would be their greatest common factor. So these are my two solutions. By the fact that I got two rational solutions, I can tell that I could have factored. So could have factored there as well. Maybe that would have been quicker. I just wanted to show the quadratic formula. Okay, so sorry. See if I have enough room for number 9 here. Okay, number 9, it says find the exact solutions. What we mean by that is we don't want you to go in your calculator and take 4 divided by 3, and get 1.3333 and just say, oh, okay, that's about 1.3 or negative 1.3. So we don't want you to do that. We want exact solutions. So for number 9, what we can do is we can clear fractions by multiplying both sides of the equation by 9. I'm picking 9 because that's the least common denominator. So I will be able to clear all fractions by multiplying by 9. So on the left, I have 9x squared minus 12x minus 1. On the right, we have 0. Now, I'm doing this in my head, but really when I take 9 over 1 times 4/3, I'm just cross-canceling in my head here. So that's where I got that negative 12x from. And if you have a decent scientific calculator, you'll be able to do that in your calculator. It does not factor. You could attempt to if you wanted to, but I know it doesn't factor. So once again, I'm going to use the quadratic formula. My A is 9, my B is negative 12, and my C is negative 1. So x equals, I've got quadratic formula right up here, negative B, so 12, plus or minus the square root of 144. Remember, B squared is always positive, minus 4 times A times C, all over 2 times A. This is another one where it kind of looks like we're going to get a negative underneath the square root, but we won't, because what follows the subtraction symbol is a negative 36, a product of negative 36. So it's going to be minus a negative. So it's going to be 144 minus a negative 36. Sorry, that's all underneath the square root. So plus plus. So we're going to have 12 plus or minus the square root of 180 all over 18. To simplify the square root of 180, I could make a factor tree again. For this one, let's just see. I know 180 is divisible by 4. And then it looks like 36. Okay, so let's see. If I take 180, 36 I think is the biggest perfect square. Yeah. So it looks like it reduces to 6, or simplifies, I'm sorry, to 6 square root 5. Some of your calculators I know will do that as well. So 6 square root 5. And then the best answer would be reducing this. Looking at all the numbers, not counting the 5 because it's under the square root. So looking at 12, 6, and 18, the greatest common factor of 12, 6, and 18 is 6. So I'm going to divide 12 by 6, I'm going to divide 6 by 6, and I'm going to divide 18 by 6. So best answer here would be 2 plus or minus square root 5 all over 3. Number 10, we have the square of a complex number minus a complex number. When you square a complex number, you do need to FOIL. When you subtract, just make sure you subtract both the real part and the imaginary part. So both signs will change. The 9 becomes negative, the negative 2i becomes positive. When I FOIL, 6 times 6 is 36. 6 times 5i is 30i. 5i times 6 is 30i. And 5i times 5i is 25i squared. I'm just going to copy then what I had back here, minus 9 plus 2i. I squared is negative 1. I'm not going to combine like terms yet. Let me go ahead and just copy what I've got. But this 25i squared is going to become a minus 25. Let me show you why here in just a second. So if I replace I squared with negative 1, so this is just negative 1 right here, then I can see that 25 times negative 1 is just going to be negative 25. Combining like terms, 36, negative 25, and negative 9 are all like terms. We'll combine those. 30i, 30i, and 2i are like terms. We'll combine those. Final answer is, so let's see, 36 minus 25 is 11, minus 9 would be 2. 30i, 30i, 2i would be 62i. To simplify a quotient of two complex numbers, we do that by multiplying the numerator and denominator by the complex conjugate of the denominator. The complex conjugate of 4 plus 3i is 4 minus 3i. So in the numerator here, we're going to FOIL. Multiply those together. In the denominator, also going to FOIL. You can, if you want, in the denominator. I call it a lazy FOIL, but anytime you're multiplying two conjugates, the middle terms will cancel. So if you want to do a lazy FOIL in the bottom, you can. In the top, make sure you do a complete FOIL. So in the numerator, I have 12 minus 9i minus 20i plus 15i squared, because I've got a negative 5i and a negative 3i, so positive. In the denominator, 16 minus 9i squared. Now we saw in the last problem that I squared is negative 1. So I'm going to replace this I squared with negative 1. It's going to change it to a minus 15. Same thing down here, but it's going to change it to a plus 9. So after replacing I squared with negative 1 in the numerator and denominator, I now have 12 minus 9i minus 20i minus 15 all over 16 plus 9. Combining like terms gives me negative 3 minus 29i all over 25. Now we're not quite done yet. It does want our answer in the form a plus bi, meaning they want to see the real and the imaginary part of the complex number. So we do have to split at the very end here. I'm going to put each of the terms of the numerator individually over the denominator. So final answer is negative 3/25 minus 29i over 25. So that would be proper standard form of a complex number. Just a couple more in this video, and then there's a second video with the second half. For an absolute value equation, we first want to isolate the bars. I'm going to let the bars be like a B. So I'm just going to show you so B stands for bars. So we have 3 times the absolute value bars, 2x minus 1, plus 14. So if you were trying to isolate B, the bars, you would first subtract 14 and then divide both sides by 3. So we're going to do the same thing for this problem here. To isolate the bars, we're first going to subtract 14 from both sides. And this is going to give us 3 times the absolute value of 2x minus 1 equals 29 minus 14 would be 15. And then I'm going to divide both sides by 3. We do not want to distribute the 3. We never distribute over absolute value bars. So absolute value of 2x minus 1 is equal to 5. We're going to get 2 solutions here. Because if the absolute value is equal to 5, it means what's inside the bars could be 5, or what's inside the bars could be negative 5. So we'll want to set ourselves up 2 equations. When I solve the one on the left, I'm going to get 3. I figure you guys can do this. Add 1, divide by 2. Over here, same thing, add 1, divide by 2, and we get negative 2. So our 2 solutions are 3 and negative 2. You could always check your answers in the original equation. They will both work. If you plug in 3, you're going to get 5 inside the bars. Absolute value of 5 is 5. If you plug in negative 2, you're going to get negative 5 inside the bars, but absolute value of negative 5 is still 5, so they both work. Last one in the video for this first part is this square root equation. Square root equation, we isolate the square root. In this case, we're going to subtract 7 from both sides. And then we can square both sides of an equation. This is helpful because when you square a square root, it disappears. It undoes the root. So squaring the square root of 3x plus 4 gives you 3x plus 4. Squaring 4 gives you 16. And then you just solve the remaining equation. So solving the remaining equation, it looks like we get x equals 4. We do want to check our solutions for square root equations. Anytime we have an even index, there is the potential of an extraneous solution. So let me just do a really quick check just to make sure that this is a good solution. So if I plug 4 back into the original equation for x, I want to see if this is true. So let's see, underneath the square root, we would get 16. And the square root of 16 is 4. And sure enough, it works. 4 plus 7 does equal 11. So we're good. So this is a good solution. All right, as I've mentioned a couple times, there is a second video. This is the end of the first video, but check out the second video for the remainder of the review.